Hello everyone, welcome to Target45. Today we are solving conversion problems, that is decimal to binary and binary to decimal. So let's start coding. If you still have not subscribed to Target45, please subscribe to Target45. So I am writing a class name number converter. So for now let it be an empty class. So the execution of the program starts here with this line. It first checks whether this program is running as a script or it is being imported as a module. So here we are running the script directly, so this condition is satisfied and it starts execution from here. At first I need decimal number, so I am taking decimal number as 10. We are converting decimal to binary first. Decimal to binary, let's understand. Decimal to binary, let's say we have 10. We have to represent it in the form of zeros and ones, that is a binary format. How can we represent it? We have to multiply ones with powers of 2 starting with the power 0 from left to from right to left. So basically from here we have to multiply each number with 2 powers of 2 and check how we can get the decimal number for 10. So let's have this first, the simplest format. So the first number is 2 power 0 and the second number is 2 power 1. The third number is 2 power 2. The fourth one is 2 power 4, 2 power 3, and it continues. For now, for 10 I am explaining. For 10 what happens? According to this, 8, 4, 2, 1. So in order to get 10 we need 1. So we need to make it as 1. We don't need 4 here, so it should be 0. We need 2 here because 8 plus 2 is 10, so 1. We don't need 1, so it is 0. So this is how we calculate the binary format of number 10. The powers of 2 starting with the power 0 from right to left. We calculate with all the ones and we multiply with it. Wherever we need this number, we mark it as 1. Wherever we don't need the number, we mark it as 0. And when we add the sum, it should be the decimal number which we are looking for. Here we get 8 plus 2, that is 10. So this is the explanation for this. I hope you understood it. Now let's write the code. We need the binary number. For that I am calling a method from the number converter class. I'm not creating any object here. I'm directly calling the method from the class because we don't need any instances here. So I have called. Let's write a method here. Ef decimal to binary, passing n, and here we have to check if the number is less than 0. If it is less than 0, we have to raise a value error. Input must be a non-negative. integer. Otherwise, what we have to do is we have to return the binary format of the decimal number. For that, we will use the bin function. So let's first print the bin function in order to understand what it is printing, and if we have to do anything on the top of it. So let's print bin n. We are calling, okay, it will print. Let's run this. Okay, number converter. I might have done some spelling mistake. Number converter. Okay, there is a spelling mistake, which is very nice. Here it is tr and here it is tor. So okay, let's run this. See, now we have got for 10, we have got 1010. If you see here, what is the format? 1010. So we have got the correct output. For 10 it is 1010. If we see for 20, it should be 10100. Yeah, imagine that there is 16 here, and in order to get 20 you need to calculate 16 yes, 8 no, 4 yes. That is why 10100. And here we don't need the 0b in front of this this whole binary format. So what we'll do is we'll replace that 0b with the empty text using the replace method. 0b comma 0b. Okay, now let's see if we have that 0b. No, we don't have. So we are using replace method in order to replace that 0b with the empty text. We have to return this. So let's return this, and let's print here. We write a print statement. Print. We are using f strings decimal. We can place the expressions in between the f strings. Here we have decimal number is converted to binary format. Binary. So between the parentheses, I have to write binary number. I have to. Okay, this is done. Let's run this. Okay, now it is working fine. The decimal number is 20 and the binary version of it is 10100. In the same way, now let's do for binary to decimal. So binary to decimal is the reverse of it. Let's say we have 10100. We have to multiply it with powers of 2 starting with 0 from right to left, the same format. And we have to take the sum of it, and we can simply do it with the help of a simple int function. We have to pass the binary number and we have to give the base as 2. This will help us in getting the decimal format of the binary number. So let's write a variable which is binary string. The binary string has to be in the format of 10. So we have this 10100 decimal underscore number underscore converted equal to, I'm calling the method on the class number converted dot. Now we have to do binary to decimal. Binary to decimal. I have to pass the binary string. Okay, and print the binary binary underscore string decimal decimal underscore number underscore converted to close this. Let's run it. Okay, we have not defined a method which is df binary to decimal. We get b here, and here we have to check a condition, which is it has to be in the form of 0 and 1. If it is not in the 0 1 format, we can clearly not perform the binary to decimal conversion. That is why what I'm doing for bit in b, bit in 0 1. If this is true, all of the bits inside the string has to be in the 0 1 format. If it is not, we have to raise value error saying input must be of the format binary, which is 0 and 1. Now if it is not the case, if all are in the format of 0 and 1, we have to return int b comma 2 base 2. I have already explained here, using this function we can do this conversion. So basically we simply have to use this int b comma 2. Let's run this. See, we have gotten 20. This is how we can do the conversions for both decimal to binary and binary to decimal. I hope this is clear. If there is something which you did not understand in this program, please comment in the comment section. Thank you.